So this is our lecture number 9 in the series of logistic regression. Okay, today we are talking about hyperparameter training and random search. So in the L1 and L2 regularization technique, we are already learned about the hyperparameter in logistic regressions. There we have taken the hyperparameter as lambda. Okay, lambda is our hyperparameter in logistic regression. Hyperparameter. Okay. Okay, in short, I have writing just a hyperparameter. Okay. So we already know that if our lambda is equals to 0, then our model is all around overfitting model. We have learned it in L2 regularization as well as L1 regularization. If this is infinity, then what? Then this model is called the underfitting model. I'm not discussing it again. If you forget it, I request you please go to this lecture. You can find it. So now the main question is that how to determine our base lambda. This is the main task. To tuning the hyperparameter, the main task is we have to determine the best hyperparameter that minimizes our optimization problem. Okay, so the question is how to determine the best lambda. Okay, this is our main question. So we see in KNN, what is the hyperparameter in KNN? We see it in KNN, our hyperparameter is all about K. And in naive base, what is our if we call it naive base, that is simply Laplace smoothing. If we use the Laplace smoothing in our naive base, then our hyperparameter is all about alpha. We have already learned it. Laplace smoothing, I think spelling is correct. I am very weak in English spelling. This hyperparameter is called alpha. And our logistic regressions hyperparameter is all about lambda. Logistic regression, this hyperparameter is called the lambda. So how we determine? Simple. We have our, suppose if we consider this model as K in NN, we have K values ranges from that is 1, that is 1, 2, 3, 4, K. So and we corresponding error, that is error. How to we calculated this error? We have calculated this error through the cross validation. We have calculated the cross validation error and compare it and just plotting the graph and just suppose this is our graph. In cross validation we get it. So in this case, if we consider what is our best K in this case, if we consider this model, then our best case is all about where? In about 4. So in such cases, our best hyperparameter is all about 4. Okay, so we see that in KNN and our we take the K value as integer. So in KNN is an integer. In an integers. So it will like between 1, 2, 3, such kind of value we have seen in KNN. Now the question is, but in logistic regressions, our lambda is not an integer, it is a real number. Lambda in logistic regressions is a real number. it is a real number. So if it is a real number, then we cannot find its specific value. So alpha is what? Alpha is nothing, all about 0 point something, some value. Suppose let's take 1 5 3 9 2 lambda, it's 2 5 6 6 something else, as value as you can take, because lambda is a real number. So in such cases we have used grid search technique. Grid search. So let's discuss about grid search. What is grid search? Grid search technique, as well as we can alternatively call this technique as brute force technique. Technique. So grid search, or some authors are called it as a brute force technique. So if we consider the value lambda, so simple. First, what is brute force technique we are discussing, then step by step. So what is, if we take our lambda value is first choosing a simple a value. Suppose we are choosing the lambda as a small number, 0.001. Now we just stepwise increasing the value as you like. So just as a 10 multiplication. So, suppose as an example, we have taken this value, we have taken stepwise as the multiply of 10. So our next value will be 0.1. Then our next value will be what will be, if we multiply 0.1, then we have 1, then we have 10, then we have 100. So this value here we are taking here, this is the multiplied of the previous value, to 10 into 10 into 10. All the value are multiplied from 10 in previous value. Similarly, if anyone choose the value as randomly as an integer, he can choose. Suppose anyone can choose as an integer, suppose 1 2 3 4. So I suggest you choose the lambda value in brute force technique, choose the lambda value as a large interval. So easily we can visualize how. If we choose this value, suppose 1 2 3 4, then we cannot understand where the lambda minimizes. So I suggest you please choose this lambda value as a large interval. Okay. So if we choose this value as a large interval, then suppose anyone choose this value lambda. Suppose I am taking an example between minus 10 to the power 4 to I have chosen plus 10 to the power 4. This is a large difference, large interval. This is it. So I am taking the gap is here 10 times, minus 10 to the power 3 minus 10 to the power 2 minus 10 to the power minus 1, then what, then 1, then what, then 10 square, then 10 cube, then 10 to the power 4. So anyone goes, suppose in our optimization problem, if we draw our graph, we can plot this kind of. So this is our lambda value. This lambda value is lying between 10 to the power minus 4 to 10 to the power plus 4. We have got this value, and this is our cross validation error. Okay, this is our cross validation error. So if we plot this at this range, if you plot this graph, suppose we are creating this graph as like this. So in this situation, suppose we got the minimum value where, here we got this, our minimization value is here. So suppose this value, let's take this value is all about 10 to the power, suppose 10 to the power minus 2. So 10 to the power minus 2, we got this minimized value. Okay, actually this value is not a 10 to the power minus 2. It will be something 10 multiply of 10 to the power something. Suppose if we call it as 0.3, suppose this value is 3.9 into 10 to the power minus 2. Actually this value is this, but as the easy of our understanding, So we can easily understand that if something in the near about of 10 to the power minus 2 our minimization value lies. So such kind of techniques is called of grid searching or root search technique. So we first we have to take a large interval, then according to we partition this interval of some numbers. So we are now testing the cross validation error, and in which point we got the minimization cross validation error, then we can think that about near this point our actual minimization lambda optimal lambda is lying at near this point. Okay, so now all about the elastic net. So in L1 regulation and N2 regulations we have learned about the elastic net. Simply this is not a neural network. Simply first previously I am already speak about that elastic net. So simple what here in elastic net we have here taking the two parameters, that is lambda 1 and as well as lambda 2. Lambda for what? For L1 regularization we have taken the lambda 1 and lambda 2 is for L2 regularization. Okay, now in such scenario we have two parameters, two hyperparameters, that is one is lambda 1 and another one is lambda 2. That is two kind of hyperparameters, two hyperparameters. Okay, so here this is our cross validation error. Suppose in one axis we are lying in lambda 1, another axis we are lying in lambda 2. This is our cross validation error. Suppose let's take our lambda 1 interval lies between 10 to the power minus 3 to 10 to the power plus 3. And we are dividing this interval as multiplication of 10 times. So it will be 10 to the minus 2, next 10 to the minus 1, next will be our 10 to the power 0, next will be our 10 to the power 1, next will be our 10 to the power 2, so 10 to the power 3 as well. Okay, similarly we are dividing this interval lambda 2 as well, 10 to the power minus 3, 10 to the power minus 2, 10 to the power minus 1, 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3. Okay, let's assume we are dividing this interval as this. So now they are have suppose let's consider they are have m number of points m1, and here we are dividing this interval as m2 number of intervals. Okay, so here if we just taking the pair of points, then we can draw easily, we can draw to a plane, grading plane. Suppose for is interval, this suppose this is a 10 to the power minus 3, this is a 10 to the power minus 2, 10 to the power minus 1, something dot, and here it is our, suppose let's take it is our 10 to the power 3. Similarly for here also we are getting 10 to the power minus 3, 10 to the power minus 2, 10 to the power minus 1, 10 to the power minus 3, suppose 10 to the power 3. So here we have generated this kind of grid. So this is a pair of points, this one, this one, this one. Here we are generating these kind of grids. Okay, here we are generating this kind of. Okay, so what kind of number in the grid appear here? Simple in 2D plane, and simply what it will be m1 into m2, m1 into m2 number of points appear in our grid, lies in our grid. Okay, as simple as, I think till now. So all are clear. So now the one thing is that in grid search, the hyperparameter, if you want to train a model, if suppose when we learn the deep learning, then you can see there have many tons of the hyperparameter. Suppose in a model there have 10 hyperparameters, 100 hyperparameters. You have something else to 1000 hyperparameters. In a very complex model, there may be any 1000 hyperparameter. So in such situations, what happen? Let's see about it. Suppose we have one hyperparameter lambda 1, one hyperparameter, and suppose it takes the value m1. Suppose in the range lies the hyperparameter is, suppose we are generating the m1 value. So how much time? m1 times. So in such case, we have to train our model m1 times something, because of our in the hyperparameter lies in the such interval that we have divided in m1 number of points. So we have to train in each point, so we have to train our model in m1 times. m1 times we have to train our model. Okay, if suppose we have two hyperparameters, let's take it as a two hyperparameter, lambda 1, lambda 2. Parameters, then what times of? So m1 into m2, simply times we have to train this model. We have to train our model. If similarly, if we have 3 hyperparameter, then how much time it will take? So 3 times. 3 hyperparameter. So m1, m2, m3 times it will take to train our model. So if similarly, if you have k hyperparameter, how much time? So if we have k hyperparameters, then we will take m k number of times to train this model, to train our model. Suppose let's consider our each hyperparameter is equally divided in equal number of points. Suppose here m1 is equals to m2, m3, okay, is equals to m. If we consider each hyperparameter is divided in same number of points, then how much time in this case, then how much time it will take? It will take m, here what time? M square time, here what time? M cube time, here what time? M to the power k times it will take. So we see that as hyperparameter increases, the number of training of our model increases exponentially. Okay, so just if we write it as our simple, has means we are call it as number, denoted for number. We have for number we denoted in mathematics has. Or number of hyperparameter increases, then what? Then the number of times the model needs to be trained. Increases the number of times the model needs to be trained. Increase what number? In exponentially. So you can see for increases of hyperparameters, our to train our model, we have increased that. It is increased as dramatically, that is exponentially. We have to, it is increased. Okay, so this is a very bad situation. So if when we learn the deep learning model, then you can see there have tons of hyperparameter. So in such case, there needed a huge amount of time and a huge amount of resources to train a model. So it is very costly and time taking matter. So it is not possible in sometimes for if you see an internet company or something, medical company or something else where we have need a model for a low latency model, then this kind of parameter tuning is not possible there. Okay, this is a very bad situation. So you see, when k increases, our m to the power k increases exponentially. Now they have another search technique, hyperparameter. This is called the random search. Random search technique. Okay. In random search, what we have done in the search, we have seen that we are in just first we are taking a hyperparameter, then we have just divided it some number of points, then we are just plotting this our cross validation here. Here we are not taking this point as interval. Here we have taking the point as random. Suppose our hyperparameter is lambda, and it lies this value between 10 to the power minus 4 to 10 to the power 4. Okay, so here first what we are doing here, we have randomly pick a values in this interval. First we are doing that, we have taken the random value, pick a random value from this interval, value in this interval. Pick a random value in this interval. So if you learn our model to train to search a hyperparameter, then you can see for the grid search technique, random search technique is better. It is a better technique from grid search. It is as good as grid search. When our hyperparameter is large. When our hyperparameter is large, then our random search is as good as grid search. So random search is a modern technique. Almost it is used in deep learning. In deep learning, when we learn the deep learning, then you can see the almost maximum cases for hyperparameter tuning, we are using the random search technique because it is as good as grid search technique. So at the end of this lecture, what we have learned, because lambda is a hyperparameter in logistic regression, learn that in grid search technique and random search technique to search a hyperparameter. Grid search and random search. So here we are dividing our interval as like this: 10 to the power minus 1, 10 to the power 0, 10 to the power 1, 10 to the power 2, such kind of. We have first divided this, then taking each point and just plot, finding the cross validation number. And the random search, what we are finding, first picking we are in the interval, between the interval we are picking the random value and just find the cross validation error. And for we are finding that random search is better from to the grid search when our hyperparameter is set of hyperparameter is large. This is the better indicator. This is better from the grid search techniques. Now just go to the sklearn library. Already these two type of hyperparameter tuning are available. Just go to the, you can see from the here already in the hyperparameter. If you just find the Google grid search on sklearn, then just type this in Google, then you can find this link. Here you can see that there have already inbuilt functions, that is estimator get params in this function. Okay, in this function there have two types of search technique, that is one is grid search technique, and another one is random search technique. Okay, and grid search technique is only used for here finding the lambda. Then when there have the two hyperparameters lambda or lambda, here we can using the grid search technique for finding the, but random search technique is used to finding lambda as well as for k nearest for k in n, k for finding the best k we can use here random search, as well as for finding the alpha for ni base, to finding the when we are in ni base, when we are using the Laplace smoothing, then for finding the lambda hyperparameter, then random search as well we can use to find the best. So it is simple, you can simple find, just type this function and simply call the what kind of search you have needed, then simply it is as simple as in Python. Okay. I think all the concept is clear, and in this lecture this is the sample hyperparameter we have to find. Okay, so thank you.